Compound interest is not some banking mystery, it is just repeated multiplication written compactly. Say you deposit a principal capital P at an annual rate, R, split into n compounding periods per year. After the very first period, your balance is the original amount times the quantity 1 plus R divided by n, and you apply that exact same multiplier again and again, period after period. Do this for n times t total periods, and you get the formula A equals P times the quantity 1 plus R divided by n, raised to the power nt. This is nothing more than the same small multiplication happening over and over, stacking on itself. Let's plug in real numbers. P equals 1000, R equals 0.05, n equals 12, and t equals 2. So we have $1,000 at 5%, compounded monthly, for 2 years. Working it out, A equals 1000 times the quantity 1 plus 0.05 divided by 12 raised to the power 12 times 2, which equals $1,104.94. Now watch this formula come alive as an actual three-dimensional surface, with compounding frequency, n, and time, t, as the two floor axes, and account balance rising up as the height. This surface plots A as a function of n and t, equal to P, times the quantity 1 plus r divided by n, raised to the power nt, over a small range of values. Rotate around it and you can see the surface climbing steeply as time increases, while barely changing as you increase the compounding frequency. That happens because more frequent compounding gives diminishing extra growth, approaching a smooth limiting curve. The continuous compounding formula A equals P times e to the power RT. Like and follow for more math tutorials, one idea at a time, nothing rushed.